Here we are at example 6 from our 4.5 set of notes. We're looking at real-world applications with these. And so for number 6, it's asking us when an object is dropped, its height h can be determined after t seconds by using this model. And this is actually a pretty common model, okay? Where s is the initial height, and we're asked to find the time that it takes for the object to eventually hit the ground, okay? So again, these are very common application questions with quadratics. An object dropping. In the future, we'll talk about an object launching. And it does follow this formula where you see h, typically it's h of t equals negative 16t squared. Plus, in this case, we're talking about that initial height being s. A lot of times it's referenced as this, h of 0. And that little 0 just represents after 0 time has passed that initial height. But again, it just means really the same thing as this s. So now what we're going to go ahead and do is we're dropping it from 100 feet. So that's not the final height. That's what this guy represents. This is the final height. Instead, that 100 is our initial height. Basically, if that object were just dropped and it goes down, how long would that take? So we have negative 16t squared. We don't know what the time is, but we are dropping it from 100 feet. Okay. And the final height, if it's dropping, we're asked how long is it going to take until it reaches the ground? Well, the ground generally represents 0 feet, so that's why the final height is going to be 0. And now our goal is to try and figure out, okay, how long does this take? Well, there's a couple different ways that you can do it. Generally, what we're going to go ahead and do is subtract this 100 from both sides. Here it cancels, leaving us with negative 100 equals negative 16t squared. Then we're going to go ahead and divide this coefficient of negative 16. Cancels out. You get t squared is equal to negative divided by a negative is a positive. Simplifying this up comes out to be 25 over 4. And now, since we have t squared, we don't want the t being squared. We just want time t. We're going to take the square root of both sides. Square root comes together with our squared, leaving us with just our time, equals. And since we've done that square root on both sides, we've introduced that plus minus right then and there. Now, there's some properties with square roots that say that you can separate these two square roots if you're talking about a quotient. And what that would look like is you have plus minus the square root of 25 over the square root of 4. And there are some other rules that say you can't have a square root in the denominator. Fortunately for us, we have the square root of 25 is just 5, and the square root of 4 on the bottom is just 2. We have our plus minus. Now, this plus minus says that it's going to be 5 over 2 seconds or negative 5 over 2 seconds, which comes out to be a time of 2.5 seconds. Okay. Well, if you consider, you can't really have negative time, and so as a result, you would get rid of the negative version of that. Okay. But again, though, that is example 6A from our 4.5 set of notes.